Okay, good morning to our lecture in macroeconomics. And we are in the stage that we are looking at theory. We started with the so-called Keynesian economics, Keynesian cross, where we looked only at the commodity market. And now we will start to expand our theory. And the first step was that we want to connect the goods market or commodity market with the money market, because until now we have not dealt with money as maybe the main medium of exchange in our economy. And these two markets will be connected, of course, via interest rates, because at first investment in the commodity markets is dependent on interest rates, and we already talked about the demand for money, which is also dependent on interest rates. And then we said the commodity market, there we have the equality between production and demand, or this can be translated into the equality of investment and saving, and IS, investment, as saving. This is because why we then call the curve, which we will deduce from the commodity market, and which will give us a connection between interest rates and production, we call IS curve. And at the money market, liquidity preference meets money supply, just demand for money and supply for money. And from this, liquidity means money supply. From this, we have the abbreviation of LM, because from the money market we also will obtain then dependence between interest rates and income Y. And then we talked about the direction of the dependence of interest rates and investment, and of course this will be negative. And we had two arguments. The first one was the marginal efficiency of capital. And so to speak, we look at an investment project, and then we can calculate an eternal rate of return of this specific investment project. And then we compare this with the interest rate at the capital market. And we will then invest in all projects where the expected yield will be higher than the interest rate at the capital market. And so to speak, we will invest in less investment project if the market interest rate will rise. And therefore, from this argument of marginal efficiency of capital, we obtain the negative dependence of investment on interest rates. And well, then we can make the general argument of opportunity costs. I have two alternatives: investing in a project or investing at the capital market for the general interest rates. And then we can say that the opportunity costs of investment are rising when the capital market interest rates will increase. So these are two arguments that we have here in general. Investment on interest rates, the dependence will be negative. Well, and now we will take this dependence and incorporate this on the commodity market. So here at this slide, let me move this a bit to the left. We are looking just at the commodity market as we had it when we looked at the Keynesian cross, and now incorporate this investment of dependence on interest rates. So still we have YD is C plus I. So Y was dependent on income. I is now dependent on interest rates plus G. And then, since we have here on the axis no interest rates, we just think where would be our total demand when we look at a specific interest rate I equals I1. Suppose I equals just any interest rate I1. Then, of course, we have YD dependent now on the specific interest rate I1 equals C0 plus I of now I1. Oh, yeah, sorry. There it is. No. Okay. C0 plus I dependent on I1, government expenditure, and the dependence on income. So for a specific I1, this is still just any number. So actually now nothing changed due to the compared to our argumentation with the Keynesian cross. This is still the part on the vertical axis. So still we have here, we are starting somewhere here, and this is now C0 plus G plus I of I1. And then with our marginal rate of consumption, we are increasing less than 1. So this is YD dependent on interest rate. I1, this is our 54-degree line. YD equals Y. And so now we obtain here at the intersection an equilibrium income Y star of this dependent on these specific interest rate. Okay? This you have to keep in mind, that we are now not only looking at Y as a variable, but also on I, but we think that this is just a specific number. And then in this picture, at first nothing changed, but now our equilibrium income is dependent on this specific interest rate. And now we put this into a new diagram, vertical axis interest rate and horizontal axis income. And then we see we have this specific income dependent on interest rate I1. And on the vertical axis, we just put our I1. And this, since it is any number, we suppose this would be here. For example, it could be 4% or something like this. Okay? This is just the conceptual picture. And now we want to know what happens if we if we decrease our interest rates, or decrease. Now decrease interest rate I1 to I2. So we have I2 is smaller than I1. What happens now in this diagram here? What happens in the YDY diagram? Any idea? Just have a look, where do you have the interest rate? In which variable do you find the interest rate in the first diagram? Yeah? Yes, if we look here at the investment. And now you have to think what happens with our volume of investment if interest rates are decreasing. What happens to this number here? These are like positive interest rates or interest on. Yes, you can think of that maybe I1 is 4% and I2 is 3%. It is just the market interest rate we have here. It is this interest rate we argued here, the dependence of investment on market interest rates. Then we also maybe have a linear function, but maybe, okay, we don't know, but well, we right now we haven't made any assumption about how this function look like in a specific way. We have only made one assumption about investment and interest rates. And what assumption was this? If you look at this slide. What happens to investment if investment decreases compared to some starting value? So if the volume of investment in our society, in our economy would be at a level of 4%, let's say 400 billion euros. What happens then to our volume of investment if the market interest rate decreases from 4% to 3%? Really? Yes, because you have here this negative dependence. If it's linear or something like this, we will see afterwards in an example. But we definitely know from our assumption, if interest rates are falling, decreasing, then investment has to rise. So I of I2 is larger than I of I1, since we have a negative dependence of investment on interest rates. So if we now know that we have to insert a larger number in our total demand YD, since interest rates has decreased, what happens in our picture? In the first diagram. What happens then to our total demand? If you look how total demand is defined, where does something change? It changes something here. And this means for our function, yep, yes, definitely. Just the point at the vertical axis. We have to insert now here a higher number, and this just means that we have a parallel shift. The slope doesn't change, but only the point at the vertical axis. Okay, so we obtain a parallel shift of YD, and this is then YD of I2. And let's take another color. YD of I2. And then this will be C0 plus G, nothing changed, plus I of I2. And then, of course, since investment has risen, we obtain a higher equilibrium income now depending on our lower interest rate. So if we put this number down here, then this number corresponds to a lower interest rate than I1. So we are somewhere here. Still, you can think of 4% and 3%. So then we have here one equilibrium income depending on interest rate I2. And here we have this other equilibrium income depending on I1. And now, of course, we don't know where interest rates are. So this thought experiment we have to do for all possible interest rates. And if we make these for all possible interest rates, so another I3 even smaller than I2 or an I0 larger than I1, then we obtain here always also other equilibrium incomes depending on these other interest rates, and altogether we obtain this falling curve, which is the locus of all combinations of equilibrium income and interest rates in the commodity market. And this we call then the IS curve. So on this line, we find all possible combinations of income and interest rates where the commodity market is in equilibrium. So this is maybe something similar we did here with our 45-degree line. The 45-degree line were also all possible equilibria where we have the equality between total demand and production. And now this line here represents all possible equilibria of interest rates and income in the commodity market. And now we have a second market, our money market. And there we are already have talked about money demand. Remember when we talked in general about money, we deduced from the transaction motive and also the precautionary motive plus precautionary motive, a positive dependence on income, but also from the speculative motive, or also we talked there also about opportunity costs, that we assume a negative dependence on interest rates. And now we have also to model money supply. And there we already talked about the central bank. We talked especially about the balance sheet of the central bank, which represents more or less something like the money base in our economy. And so now we suppose that central banks can set the amount of money. This is an assumption. In reality, we know that there's a steering process via interest rates and so, but here at this step in our model, we assume that more or less the central bank can set the amount of money, of nominal money, of course, M. What really counts is the real amount of money for us, because it doesn't matter if we have 1,000 euro. It's interesting what we can buy with our 1,000 euros. So we divide this nominal amount of money by the price level P, and then we obtain the real amount of money. Here already the price level enters, because in the next step we want to flexibilize this price level, but right now we just assume that still price level is fixed. So this is just a fixed number in the ISLM model. So, and if this is a fixed number, then of course the central bank can also set the real amount of money, since they can set the nominal amount of money and prices are fixed. And then money market equilibrium would be just if the condition M equals M over P equals L liquidity preference of Y and I are equal. Condition. And now we want to analyze this condition here. And again, we start similar to the argumentation for the IS curve. We just have a look here at the money market. Well, let's also write here that this is the commodity market. So, and now money supply. If the amount of money is set by the interest rate, how does money supply look like when on the vertical axis we have interest rate and on the horizontal axis we have money demand L and money supply M over P. If M over P is just a fixed number, let's say I think M1 we had in the Eurozone was roughly almost 10 trillion euros. How does a fixed number looks like in this diagram? Think of it's just 10 and the unit is trillion euros. So if you have, for example, f of x equals 10 and here you have f of x, equals 10 and here you have f of x and here you would have x. Yeah? Or vertical, no? So maybe we should start the other way around. If you have f of x here and x here, then of course f of x is 10 would be here this horizontal line. And now this is always the case. I think I already talked to you about this, that economists quite often interchange the axes. P and X in demand and supply curves are if you look at market equilibria are also interchanged. So if we then interchange these axes, then of course it is, as you mentioned, a vertical line. So this would be just one fixed money supply. And now, since we have here only interest rates, we also suppose, like in the argumentation in the commodity market, that we now fix not the interest rates, but L of yi, we fix now the income at a specific number. Suppose y equals some fixed number y1. If this is fixed, then we have only the dependence on interest rates left. So then this becomes only a function of interest rates. And we assumed that as investment, also the demand for money should also depend negatively on interest rates. So if we have a function which is negatively dependent on a variable, then this function is monotonically increasing or decreasing. So we have assumed that we have a negative dependence of money demand on interest rates. And then is now, since we want now to draw this function in our diagram. So is it now a falling function in interest rates or an increasing function if we have this negative dependence? So the lower the interest rate, the higher is money demand. Then increasing, the lower the interest rate. So if we go to the left here, the higher it's decreasing. Yeah. So this you really have to keep in mind that you know what this negative dependence here means. Negative dependence. So our money demand would be just any decreasing function depending on our fixed income y1 and the variable I. Still, this one is just any fixed number, so we do not have to care about the dependence. So what we then have is, we have here an interest rate I star 1, equilibrium at the money market. Money demand meets supply. But this interest rate here is depending on our fixed income at y1. Okay? So conceptually, this is the same argumentation as here in the commodity market, but there we had the equilibrium income is depending on our fixed interest rates. Now, the argumentation is the other way around. We fix income, and then we obtain an I star of y1. I should write here also I star of y1. I1 star of y1. So this interest rate depends on our y1, and let's just suppose that y1 would be somewhere here. So then we have one first possible combination of income and interest rates where the money market is in equilibrium. Well, and now we go on as in the commodity market. Now increase y1 to y2. So y1 is smaller than y2. Again, where in our first diagram here in the money market, where does income enters? Income enters only here in our money demand. Here, nothing changes. So, and now we have to think of what happens to our money demand if income is increasing. And there we remember that we have a positive dependence of money demand on income. What happens to our money demand curve L? if this y is increasing. Yeah. Not a rising, what you mean with rising slope, that it is now increasing in interest rates? Why should this change? We still have our negative dependence on interest rates. Yeah? No, the positive means here the positive dependence on income. Yes. So we don't know if it's really a parallel shift because we do not actually know the specific function on y, but we know it is positive. So we obtain, of course, somehow shift to the right. Because in this diagram, income is just a parameter of money demand. Where do we find the function? Okay? This maybe you have done in mathematics, that you maybe talked about some linear line. My is a plus bx, and then a and b are the parameters. Where do you find the function? And x is the independent variable where you you know how y is changing if x is changing. Okay? So again, we take another color. So we obtain a somehow shift to the upper right. And this is now L of y2. And then we obtain a new equilibrium interest rate for money market, I2 star of y2. We can put this here in our other diagram, I2 of star of y2. But this corresponds now to y2. y2 is larger than y1, so maybe somewhere here. And we obtain, oops, bit lower, a second equilibrium point. And also this one. So, and again, we have to do this thought experiment with every possible income y. So with lower incomes, with the higher incomes, and then of course we obtain here all the other possible equilibria at the money market. And this is then the locus of all interest income combinations where the money market is in equilibrium. Yep. The concept is definitely the same. Yes, here we are. So here we come from the commodity market. We want to deduce all possible interest rate income combinations where the commodity market is in equilibrium. And the LM curve shows us all possible interest rate income combinations where the money market is in equilibrium. Well, and now, surprisingly, we put these two curves together in an YI diagram. So these are all possible equilibria at the money market. These are all possible equilibria at the commodity market. And then, of course, the intersection of both curves gives us the overall equilibrium where simultaneously both markets are in equilibrium. So again, to summarize, we start at first with two separate markets. We look at the commodity market. There, in behind, we fix interest rates to I1, I2, I3, and look how then income to be in equilibrium changes at the commodity market. Then we obtain these dependence between interest rates and income from the commodity market. At the money market, in behind, we fix income, 2 by 1 by 2, and so on. And then we obtain a dependence between income and interest rates from the money market. And then we put both together and we obtain the overall, oh, there it is, equilibrium of the economy. Well, and now to be more specific, we take just one example and we want to calculate the IS, LM curve and the overall equilibrium. So let's start with the IS curve. What do we have to do? What was the equilibrium condition at the commodity market? We go back here. Oh, there's somewhere some guys. Or how many do we have? So over the internet, what was the equilibrium condition at the commodity market? Yep. Yes, here we are. This is the equilibrium condition. And this we need if we want to calculate it. So yd equals y, and then we just write down what is yd. Yd was c plus I plus g. So we insert for c 50 plus 0.8 times y plus I 30 minus 300i plus g equals 20. So this is g, this is I, and this is c, and this should be equal to y. So we have now to solve this, that we have, you can do it as you want. You can solve it for I, or you can solve it for y, as you like. Let's solve it for y. Then we obtain no, sorry. We look at first at every fixed number. 50 plus 30 plus 20 is 100 minus 300i, and on the other side y minus 0.8 times y. And this of course will be 0.2 times y. Multiplying with 5, we obtain 500 minus 1500i equals y. And so this is of course our equation for the IS curve. LM, what was there our equilibrium condition? Yep. Yes. And it has to be a condition. This has to be equal to what? Not M, but this is money supply, and this has to be equal to money demand, and money demand is? Yes. Oh, here this has to be I, sorry. L of Y and I. And now we just insert our specific functions. So we obtain 400 over 2 equals 0.5 times y minus 250 times I. And also you can solve this for I or for y, whatever you want. So we obtain 200. Let's also solve this for y plus 250i equals 0.5 y, multiplying with 2, 400 plus 500i equals pi. And then this is the LM curve. What do we have to do for overall equilibrium? So how do we obtain the intersection of the LM and IS curve? Yep. Yes, definitely. So IS equals IM in quotation marks, and then we obtain 500 minus 1500i equals 400 plus 500i, and then we have 100 equals 2000 I, so I star equals 100 over 2000 is cancelled, times 5 is 5%. Then of course also we need Y star, the equilibrium income. How do we obtain the equilibrium income? Hmm? So here, this picture. Now we have calculated this one. But of course, we also are interested in the equilibrium income in our economy. And if we have now I star, yeah. What do you mean with solve? I think it's a bit easier, all right? Okay. This is, of course, possible. It is actually, there are many ways to roam, Roma. Of course, this is, of course, possible. But what else can you do? I think, uh, yes, of course. It is. Let's do it. I think this you have quite often done here. If you have px and if you have demand is maybe p equals 10 minus x and supply would be, what can we say, p is 2 plus x. Supply and demand. And if you set this equal, then you have 10 minus x equals 2 plus x. Then you have 8 is 2x. So x star is 4. And how do you obtain P? Of course, just inserting the equilibrium quantity. So 10 minus 4 equals 2 plus 4 is, of course, 6. And this is, yeah, quite important that you really realize that the concepts are always the same. So now we have an increasing function. It is not the supply curve, it is the LM curve now. We have the decreasing function as in this money market, as in this classical market equilibrium's IS function. And to solve it is just the same as thing as you have done it, I think, in many other lectures, right? Okay, so we just insert our interest rate and obtain, I will do both. No, 500, sorry. Oops, where do we are? 500 minus 1,500 times 5 over 100. This cancels. 75 is 425, and hopefully we are right, because this has also to be equal 400 plus 500 times 5 over 100, and so inserting in both equations, of course, has to give us the same result. Well, let's draw this also to be complete. So what do we have? We had IS 500 minus 1,500i, 500 minus 1,500i equals y. This was IS, and 400 plus 500i. This was our LM curve. So how does it look like? Well, if we set I to 0, then we have here 500, okay, from the IS curve. So this is 1 point on the IS curve. What would be the interest rate for the IS curve, from the IS curve, if y is 0? Then we obtain the point at the vertical axis. Or just gives me a hint, what do we have to do? So here, I of y equals 0 is no, not solving for y. We are setting y to 0. Solve for I. If we set yes, then yes, yes, this is totally right. So 0 is 500 minus 1500 I, and then of course I is 32.3%. And since we know that this is a linear line, we know that this is our IS curve. How does our LM curve look like? Well, if again we set I to 0, then we would be somewhere here at 400. And for example, then let's say set y to 500, then we would be here at this point. Just you can use, of course, any number, but just to find how do our curves look like, then you have 500 plus 500 I equals 400. Sorry, and then we have 100. What do we have here? 500 equals 100. So we obtain I is 1/5 equals 20%. So we should be maybe somewhere here. So this would be our LM curve. Oops. Okay, this is just an example for our overall equilibrium. So this was our 425, and this was 5%, I think. Huh? Yeah. So almost, I think, my drawings. So the axes are almost quite good, I think. So this would be then 520. If I pose in an exam question, please draw a diagram, then you always have only to sketch it. Okay, so, and now we want to start with the interesting part, because now what happens if we are intervene via the government or via the central bank? So what happens in our economy if we are doing fiscal policy? This we already also discussed in our Keynesian commodity market, where we deduced then the fiscal multiplier, the government expenditure multiplier. So now think of we increase government expenditure by plus delta G. Again, we are in our commodity market because G we do not find in the money market, so nothing happens to the LM curve. But what happens in the commodity market if we are increasing government expenditure? Where do government expenditure enters the commodity market? Where do we find G? This is always the case if you analyze these models. You have to identify where does our variables which we want to change enters our model. Well, of course, we know YD is C plus I plus G. Yep. In YD, yes. And now in our curves, what happens to our curves in the diagram? It's just the same as we already talked in the pure commodity market. Yeah? So here, only at this point enters a change of government expenditure. So what happens then is that this is depending on G, and now we are increasing G to G plus delta G. So we obtain our parallel shift YD of G plus delta G. So this is then C0, and now this is important. Do not mix it up with the derivation of our IS curve. Our interest rate is still the same, I1 here, plus G plus delta G. So this means that now this interest rate I1 does not correspond anymore to Y1 star depending only on government expenditure G, but to a higher equilibrium income Y2 star of G plus delta G. So this means that this original equilibrium point, due to due to the increase of government expenditure, shifts to the right. So this one shifts just here to the right. Well, and now you have to incorporate our derivation of the IS curve in general. This you have to do for all possible interest rates again. So to speak, we have to derive now the new IS curve. But conceptually, to every old equilibrium point happens the same. Every equilibrium point of the original IS curve has to shift to the right. Okay? So this one to the right, this one to the right, this one to the right. So we just obtain a shift of IS of G plus delta G to the right. So increase of government expenditure shifts the IS curve to the right. Well, and now we put this result into our overall model. We know here nothing changes. In the money market, we do not find any variable G. But we know that if G is increasing, G1 to G2 and G1 smaller than G2, that this means we have a shift IS of G2 to the right. And now, of course, we have a new intersection point. So we obtain a new Y star of G2, which has increased, but also we have to go upward on the LM curve. So we obtain also an increase of interest rates. So, and if we compare this to our increase, if we have only, or if we look only at the commodity market as we did it in the beginning, then we would have this shift here. This would be increase of Y if we look only at the pure commodity market without interest rates. But now this increase of equilibrium income is not that high. And because why? Because also we have this increase in interest rates. And qualitatively, we could say that if G increases, then of course this directly happens, like we discussed it in our standard fiscal multiplier. This directly increases Y. But this increases also now in our money market. Money demand increases money demand via L of yi, since we have here this positive dependence. And this increases. Money demand has to equal our money supply. This increases I at the money market. Well, and if I has increased, then at the commodity market has to fall, because we have also the negative dependence of investment on interest rates. So investment decreases at the commodity market, and overall Y has to fall a little bit compared to the first increase. And this you can say maybe is something like this, that you at first step to this point and then you go back there. But in practice, if you want to interpret this in a somehow dynamic way, then you would say that the reaction speed, the speed of reaction is quite faster at the money market than in the commodity markets. And so we in general assume that we would shift to the new equilibrium income on the LM curve. But actually, we are not having here a model which has time t as a dynamic variable. But we have here this decrease in investment, and therefore this means increase of government expenditure. This has increased, reduces via the interest rate effect private investment. And so to speak, we have an effect that we are pushing the economy via the government, but this push decreases the private activity via the private investment, and therefore we speak from the so-called crowding out effect. And of course, it is quite important how large this crowding out effect is. And there are, of course, some economists which argue that in general, well, government activity is always worse than private activity. Please do not do it. If you are investing, so to speak, by increasing government expenditure, nothing really happened overall because you just substitute private investment. But of course, in practice, we will find this effect, and then we have to see how large is this effect. Remember when we talked about the scrappage allowance in the financial crisis in Germany? There, the argumentation was, well, we will start to buy new cars, but we just substitute and we do not buy any refrigerator or something else. So this is a similar effect which we have here now via the money market. Okay, and then, of course, we also want now to talk about monetary policy. What happens if the central bank intervenes? And how can the central bank intervene? Well, just if they increase the amount. You wanted to say this? Interest rate, this is right now we we have to admit that in practice the central banks are steering the money market via the interest rates, but in this model here we assumed that we can set more or less the amount of money. So right now we have to argue within our model. And here our assumption was, money, amount of money, quantity of money. So that this quantity of money is set by the central bank. So what we want to talk now about is what happens if the amount of money is increasing. Now, of course, this amount of money enters, of course, only the money market. So again, we have to think what happens to our curves in the money market. Where does M enters? Well, it's just only here at money supply. And what happens if this number increases? Plus delta M. What happens to the supply curve? Well, if this is 10 and now it's 12, what happens? A shift to the right. Huh? So we would then obtain delta M plus M over P as the new money supply. Well, this money demand curve, the blue line, was depending on some specific income Y0. So from this we obtained the dependence of the equilibrium interest rate on the income. Now our supply curve changed, then this interest rate is dropping, so we obtain I1 M plus delta M, a new interest rate. But now keep in mind, income has not changed, so this new interest rate, M plus delta M, now depends still on the same income. So this means that this equilibrium point is now shifting downwards. And again, this argumentation you have to do for all possible incomes. So every point on our LM curve is now shifting downwards. So then we obtain that the LM curve is shifting downwards to the right if we are increasing the amount of money. So LM shifts downwards to the right if the amount of money is increased. Well, and this result, of course, we also put in our overall picture. In a minute, I'm writing too much. Here. Now, increase of our amount of money. So M2 should be larger than M1. This means shift downward to the right of LM. So LM of M2 is our downward shift. again, we obtain a new equilibrium income, which has increased, but now simultaneously we have a decrease of equilibrium interest rates. And how is here the argumentation? Well, we have M goes up. If M goes up, then we found here that interest rates are falling. If interest rates are falling, and now at the money market, then these interest rates enter the commodity market. Then I of I is increasing because of the negative dependence of investment at the commodity market. And of course, if investments now increase, we have the increase of Y in total. Okay, 3 minutes left. Then let's look what happens in our example if we now do fiscal and monetary policy. Let's take A. What do we have to do if government expenditure doubles? This means delta G is what now? If government expenditure doubles from 20 to 40, then the increase is of course 20. Well, and now of course you can do all your calculation, not with G is 20, but with G is 40. Let's just do this, and I've written too much here. No, where's my calculation? It's over here. So then let's look at the IS curve. This was the derivation of our IS curve. So what changes? It changes just our 20 here. So we have plus 20. We have here plus 20. We have multiplied by 5. 5 times 20 is plus 5 times 20 is 100. And so we obtain the new IS curve as Y is 600 minus 1500 minus I. And then again, let's say this is SIS prime equals LM. Let's go here. What was our LM curve? This was because this didn't change. Oops. This is our LM curve. And then we obtain 1500 I equals sorry, whoops. 600 minus 1500 minus I equals 400 plus 500 I, and so we obtain I equals 200 over 2000 is 10%, and we obtain Y star is 400 plus 500 times 10%, so 450. And to be complete, income increases from 425 to 450. So delta Y equals 25, and we obtain delta Y over delta G is 25 over 20 equals 1.25, and this is then our fiscal multiplier. And here now you have this example that if you compare it with the pure commodity market, there with a marginal rate of consumption of 0.8, the fiscal multiplier should be 1 over 1 minus Cy would be 5. And here you see this crowding out effect, that this dampens the multiplier down to 1.25. Okay, then we are done today, and yeah, you can have a look at the part B at the monetary policy, and this we will do on Thursday.